It is 10 o'clock, and let's get going because I respect people's time and efforts trying to join this webinar. I do appreciate everybody joining today, and I know it takes you out of your valuable time on your work day to go through to this webinar. And the reason that we having this webinar is to help you to improve your instrumentation, involve reliability using some sort of assets management software. And so let's get to it. And again, please use the Q&A to submit your questions. As you submit them, either one of my colleagues or myself will answer your question throughout the webinar. And so hopefully we can answer all your questions throughout the webinar. And so, difficult, right? See. Anyway, my name is Tien Phan. I'm the Sales Enablement Specialist. I deal with asset management system as well as instrumentation of valve, right? I work with end users like yourself, as well as our Emerson Impact partners, as well as other Emerson divisions to put a solution around instrumentation of valve, margin, and configuration capability of an asset management system. So Eric, you want to introduce yourself?
I will. Thanks, Tim. Yes, my name is Eric Snyder, and I've been with Emerson for 28 years and always in this reliability solutions space. So today that means about a year longer than AMS Device Manager's been out. I focus on North America. I have counterparts in the other world areas, but one of my tasks is evangelizing the use of asset management solutions that you're going to hear about today.
And I'm Anna Valenia. I'm the product manager for AMS Device Manager. Been with Emerson for 20 years. And I'm responsible for providing the direction, the future direction of AMS Device Manager in Emerson.
Let's go through the agenda today. And so we have 4 topics we want to cover this with y'all, and hopefully y'all can get some valuable information to help to enhance your reliability in your plant, right? So the first topic, we're going to go to why it matters, right? Why it matters to have reliability in your plant. And then we go into, some key features of smart instruments and valve, and what do they provide to you and to your organization, how to help you define your reliability programs, all right? And then Eric will go into, key features of what you should be looking into a asset management software so that you can determine what is best for you and your organizations to do a more predictive analysis on your instrumentation valve. And then Anna will go through real world use cases. So I pick out some good one to show y'all today so that you can see what some of the companies out there are doing and how they are getting their return on investment. So, all right, you want to kick off a polling for me, Anna, and see what. So if you don't mind, there's a polling that put up in your teams. If you can answer those questions, that'd be great. Each one of these quick polling will last for 15 seconds before we go into our next topics, if you don't mind.
Yeah, so we're getting some people responding already. Gonna continue to have this open for a couple more seconds, but the top industries that I'm seeing here, 10 would be chemical and petrochem, oil and gas, and there's another, or yeah. So we can talk more to those people what those other industries are, but yep.
While the polling's going on, I just want to let you know my past experience as an end user, right? I used to be in the nuclear and food and beverage industries, and we do a lot of, plant reliability and, but without an asset management system. So I run into a lot of situations where I troubleshoot instrumentation valve, and typically what we don't find any issues. There was an actual polling by the HPI marketing data that indicate 63% of our troubleshooting in the field turned out to be no value added because there's nothing wrong with the instrumentation valve. And at the time when I was in the plant, we had no visibility of these great smartness of the instrumentation valve. So therefore, we would just go out there with the Altec or flute to check the, wiring, the grounding, make sure everything's good, right? And if we were lucky, we were able to get a handheld to communicate with the device to see the diagnostic capability of it. So, those some of the things that I run into a lot in the field, and the server, the HPI marketing data really proved my effort that I put in the field, which turned out to be a lot of waste of time, right? So there are times that where the instrument was really actually bad, right? Most times, some sort of your process control system and your PID control loop and so forth is causing some other problem or operator issues. And so, all right, let's get into it, right? One of the things, when I was in the plant, one of the biggest thing is find way to optimize to run the plant, right? How to increase savings for the plant so that we can get more earnings for the quarter, for the year that we're operating in, so that we be more profitable. When the company is more profitable, we can do a lot of different things, right? Such as more expansion, more opportunities to increase manpower, resources, and training capability in the plant if we have making more money, right? So this particular, benchmark data that I'm showing you, by improve your energy efficiency, conducting energy audit, identify inefficiency, installing energy efficient lighting, and a lot of other stuff that we do try to improve the area. But as you can see, there's only you can increase only by 3 to 5% of your earning, right? By just doing that, right? But the other things such as production, right? Adopting lean manufacturing, automation, optimizing supply chain and inventory. Those other things, those improvements also only increase your earning by 3 to 5%. But the interesting thing is if you can increase your reliability program around instrumentation valve, rotated equipment, and so forth, your incorporate in your day-to-day work practice, right? Work management, all those different things. Look at it. You are earning 7 to 10%, double of what the other initiative may be, right? So reliability should be one of the key things you need to look at how to bring your company earnings up by 7 to 10%, and that is a lot, right? And so Anna will show you some opportunity there that we will show you some of these things that people are doing that have create that earning from them. So another thing, without understanding what the asset that you're monitoring and what information given to you, a lot of people are running their asset until it fell, right? But if you run it into failure mode, right, it's gonna cost you 4 times as much to operate your plant because you're gonna run into a lot of shutdown, turnaround, your device start degrading from the beginning to when it fell, right? But you need to find a way to understand your instrumentation valve, your rotated equipment when it is optimal to have some predictive analysis around that asset so that you can catch it at P1 level when it starts affecting your control system, right? And your quality and your production, right? Because when your instrumentation valve having issues, your 4 to 20 milliamps, so forth, will also be affected. So your control of the quality, because once the batch have been made, so forth, and then they go through a quality check. If that batch is not within the quality range, you're gonna have to dump all that batch and so forth, and that is costing a lot of money as well, right? So we got to think about how we can monitor things, how we can bring information to your visibility so you can take some actions, right? Put some program around that situation so that you will not go into a failure state. So running an asset to failure, it should not be a good strategy because that's my opinion. Because we always trying to find a way to put a program together to check on things, check on equipment. Is the instrument is station good, alerts good? If you don't have the visibility, you have to do, you know, hopefully you cross your finger that your instrumentation valve is operating good performance. And so Solomon did a study in 2013, a RAM study, right, for the top quartile uh, plant, right. So for being not a top quartile plant, right, you are costing yourself 3.6 time more money to operate your plant. So think about that, right? You are very running mostly inefficiently, trying to go out there, troubleshoot on something that's not a problem, because you have no visibility on your instrumentation valve. Therefore, you are, running very inefficient. So therefore, it's going to cost you more money, right? So, most company, such as the one I was in previous role, right? We don't want to see unexpected surprises that coming up, right? We want to be more predictive. That's why we have programs, go check on things, verify things, make sure everything is plugged up correctly so water and damage doesn't cause the instrumentation valve issues, right? As well, we do not like unexpected failure, right? When there's a failure, we always try to put a program around that so that it won't happen again. But you are focused on different area and you don't have enough manpower and resources to go around to check in everything. So you will eventually catch one of those situations where we had a program around it, but we didn't have enough manpower to go check on that. And so just realize, by putting a reliability program together, you will be moving up toward the top quartile and to have more uptime and more productive, efficient troubleshooting for your maintenance folks. Okay. So this is my one of my favorite topic right here. And so understanding the feature of smart instruments and valve, right? Because in previous roles so forth, I could not understand these things. I hear from my vendors who selling me all these great instruments, all these capabilities and so forth, right? But you think about it, in the control system, we only see 4 to 20 milliamps and control things, right? We don't see the digital part information or foundation field bus information or different type of protocol that has the device descriptor that's built inside the device that the instrumentation can talk to, right? So let's go into what it's all about, right? Uh, I don't know if you know, but your instrumentation, right, is can it's kind of like us, right? There are a lot of information there. That's why I call this consumption gap because we don't understand what information is providing to us by our instrumentation involved, right? So overall, kind of like us, can sense, smell, taste, touch, whatever it is, it through the connection, the process sensor that the device has, right? It can detect abnormal situation in your processes, right? As well as the connection, on this device itself, right? As well as it know its own health. It detects and it analyzes itself to give you information. Hey, I don't feel good. I have a temperature today. I better go see a doctor to get some medication or some way to remedy me, right? So that I can stay healthy and continue running and operate at full capacity, right? Versus limping along, having headaches, can't concentrate, do my job well, right? And then the other key things about your arm, your leg, your hair. You have situation cut here and there, right? you say, ouch, man, I need to get Band-Aid or something to help me to get better over time, right? It can detect loop integrity and data integrity of your wiring, right? And then it pass all that information to your asset management system to be able to give you a visibility of what is going on and how to be more predictive on your information and maintenance for your system, right? I put, by being predictive, have predictive maintenance, right? You're going to reduce time, increase availability of your plant. This way you get your earning coming from, right? As well, early warning of electronic failure and processes. Oh God, how valuable is that to be understanding what's going on, right? It should be an extension to your day-to-day maintenance program as well as calibration interval and so forth. So everybody here should be, if you work in the plant and so forth, you should have some kind of valve that is operating in the field, right? To control thing. It could be a pressure valve, it could be an electrical valve, uh, you know, electric actuator and so forth, right? But those things, if they have gone through the field com group foundation, right, and create a proper device descriptor and so forth, right, you can actually see these information that is given to your control system, pass it on to your asset management system. You need an asset management system in one way or the other to be able to see the alert information. I call these alerts, right? Because they come in from the instrument. And these alerts could be travel deviation, right? When the travel deviation is happening, it's going to affect your quality of uh, your batch and so forth, right? And valve friction as well. Those are things that causing a lot of issues, right? And then you have to add to P the defective. You got to know that early so that you can fix that problem. The other key thing is like cycle count. I like cycle count because give me information of how much longer can I run this valve before I have to do a refurbish or replace the valve itself, right? Because it's kind of like your engine oil. Your engine oil, if you depend on your oil type you use, right, it can last 3,000 miles or 12,000 miles, right? So as you get to that mileage, you get a light notification of what's going on, right? So therefore, valve alerts do the same thing, right? Give you that information. So hopefully y'all can get this information out so that you have more visibility of what's going on inside your plant. So here's a temperature transmitter, right? It doesn't matter is it inches and Hauser or a Emerson Rosemont transmitter, right? They should have, some capability and so forth, right? Just as you think about, if they have dual sensor, if one sensor die, right, the control system will the device just do a switch over. The control system doesn't see anything, right? All they know they're still getting good temperature. They don't know if the primary sensor has failed and switch over, right? But you have an asset management system. You get an alert. You be able to detect that, write a work order, and get that uh, sensor one replaced, and then reset the device so that you can operate at dual sensor again, right? Another thing, really nice thing is sensor drift, right? When a situation over time, your sensor get corroded or build up on it and it starts drifting off, right? How you deal with that? Because that sensor drift is very important for your batch environment because your temperature and everything will be out of whack. And then you're going to have some quality issues going on and so forth, right? And there's so many other different alert capability that it has built inside itself to pass on to the asset management system, right? Because if you understand about HART communication protocol, it ride on top of your 420 milliamps. When it ride on top of 420 milliamps, it needs some way to detect and pull that information out so that it get you very valuable information into your asset management system. So, the other thing is that, over time you running good, you start up, right? Everything is perfect, right? All your sensors clean, And so over time, your tank fill up, reduces, crud start building up, right? So how you kind of like your fuel injector. Over time, your fluids flow through there. You use, regular unleaded gas versus a super unleaded gas, right? Your valve steam start be building up, right? And over time, you're going to be running very inefficient and you're going to get spurred and so forth. Right? No different with instrumentation valve here, right? Because you can get your build up, foaming, turbulence, different things happening, and then your qualities of signal start degrading. It's going to degrade so much that you can't control your process anymore because now your 4 to 20 milliamp is offset and so forth, and therefore you're gonna have some situation that could cause a shutdown or a really bad quality product of your batch and so forth. So the if you can get this information early, right, you can do early diagnostic, right, to prevent unplanned shutdown, right, schedule maintenance before incident occur, right, and you eliminate these uncertainty if you can see these information right in front of you on your day-to-day operation, right? When I was in the food and beverage, I did a shift turnaround, not shift or morning shift. Even in the nuclear industry, we have shift turnaround as well, right? We have written everything on a piece of paper, right? Trying to detect things early, notify things of what's going on, what action needs to be taken on that day. But at the time, we have no visibility of this information. Therefore, we just kind of like react on situations that's happening on a day-to-day basis. So, by as you can see, our smart information can give you alert indication. You can investigate what it is and what information it's gonna give to you, right? It's gonna give you what the event is and how to resolve that issues with actionable recommendation, actionable tasks that you need to take. So I went through three examples of some things, right? But as you can see, there's so many different instrumentations and file out in the field today, different vendors, right? You make sure, you buy instrument and valve that has a lot of diagnostic built in, but you pay for the capabilities of these devices. Why not use them to your advantages, right? Because when a vendor come to you, they're going to upsell you a lot of these capabilities, and without having asset management software of some sort, you can't see these. Therefore, you can't utilize them, and you'll be wasting your money. So, therefore, now let's look into this uh, capabilities and so forth, right? So, and I seem that there's another polling question that need to be taken and see what people are saying.
Yep, I just launched it. A very simple question if you are using the smart diagnostics today. So just a simple yes or no. Um, maybe you're not aware, so I guess not, you're not using it. But yeah,
All right, look at
it's kind of 50-50
wow,
right now,
that's
Tin.
awesome.
So that's sad and because if people are not aware of these smart diagnostics, as you said, like they have all these capabilities, they have all these smart devices, but if it's not getting used, then they're not getting the full benefits
That's great.
of their smart
Okay.
devices. So they said there's like right now there's like 51% said no, 52%. So
It's still going up and down, but very
yeah,
close.
yeah, it's
Close to each
very
other,
close.
50-50. Yes. But
Yeah,
for
yeah.
those who understand it, right, I'm hoping you are utilizing some sort of asset management software to be able
Mm-hmm.
to benefit from these smartness of these devices. So, all right. All right, I'm going to hand this one off to Eric Snyder, and he will go through what to look for in a asset management software, right? To might be mindful of what he's saying because these are key components of how an asset management software look and feel and how you make utilize of it. All right, Eric.
Okay, thanks. Yeah, thanks, Tim, for that. Yeah, that was interesting as well as far as that. It may just be that hey, you guys are aware of the fact that these devices have this capability, but maybe you're still looking for an asset management system
Mm-hmm.
to be able to take advantage of those diagnostics as well. So with that, we're curious if, hey, if you were aware of those, do you have an asset management system? So Anna's got a simple polling question up here. Maybe you're using software that we're really going to be focusing on today, or maybe you're just doing things with handheld communicators. One of the
Mm-hmm.
very popular ones in the marketplace is AMS Trek. So you might be doing it with field work, but you could also be doing it with software.
Yeah. Yeah. So we're getting a lot of responses here to Eric. So like, yes, maybe for those who knew about these smart diagnostics, they are using some type of asset management system today. But there's like 20% who don't use asset management system, and a lot of a big chunk is using handheld communicators. So they're going to the field and connecting physically, maybe to the devices. Maybe some have Bluetooth already.
Mm.
So they're connecting to the devices via Bluetooth, but you still need to be within, within range of the field device. Um, so yeah, but 50% of the respondents say yes, they're using some
Okay,
kind of asset management today.
great.
Yep.
Nice.
Okay, thanks. Thanks,
Hmm.
Anna, for that. So with regards to looking at these, one way to do that is to do the field work, but that involves going out there, taking the extra time to go to the device. Maybe an operator sends you out there. But if there's ways you look at an asset management solution, uh, product to be able to say, hey, is there a more efficient way to be able to do this? And I'm going to give you about 12 different things just to think about if you're looking at a system from different companies. And so some of these essential features to evaluate on would be, first of all, just device compatibility. Some systems out there just focus on one vendor's types of devices. Others will focus on all devices. So any HART, any foundation field bus, any wireless HART, in some cases Profibus devices. You're going to want to look at that as a consideration to say, I want to have a single system versus having multiple systems. One system for vendor one system for vendor two, and another for vendor three, right? Multiple systems, hard to train on and stuff. So device compatibility is really a big thing. And then you have these devices already out in the field, and they're connected up to different systems, different types of control systems, different types of safety systems, PLCs, SCADA systems, gateways, multiplexers. There's different ways to communicate with these. And one of the big things that people drive towards is to have one of these Ethernet type connections to these systems. So some systems, again, they just focus on talking to their own vendor's product. So it may just be it's talking to this one DCS, and you can only see that manufacturer's products through that DCS, right? So again, any manufacturer's device, you get to pick the best ones for your process. And then the connectivity is that some systems can talk to over 30 different types of systems to access that information out in the field. Then you get into more, if you're talking to this many devices, how usable is the system? Is the information clearly presented to you on the screens? Maybe you need mobile access. It could be from a phone, it could through a browser, it could be through a tablet, it could be through a Toughbook, or it could be on a desktop. Most of the access that we see is installed on a desktop where it's have clients over in the maintenance shop or where technicians are actually doing their job. So again, having a system that can be online with user-friendly information connected to these devices is a key thing to help you eliminate time or wasted time of being able to remotely troubleshoot devices. Okay. A few other things to go through are, and for the slide to advance, here we go. How are we going to be, once we're communicating through these let's say, control systems or safety system to these devices. Asset discovery. How are we going to read in all this information? Hopefully it's not going to be one device at a time, because you may have 300 devices, 500 devices. We can go all the way up to 30,000 devices in some cases with some of these asset management solutions. And so being able to say, hey, I want to scan in this area, or I want to scan in everything, just to pull in all that information on how we can not have to do it point to point, but just to bring that information in. A system like an asset management system needs to get all the information from those devices. And so something like a vibration transmitter, believe it or not, has over 400 different parameters in it. Something like a control valve may have 150 parameters in it. Some simple temperature devices may only have 80 parameters in them, but still having to pull all that information in is easier just to do it with an online system, to be able to tell it to scan and read in all that information. Then where does that information go? It goes over into what I'm calling this inventory management. You want to have a plant database, a logical structure that you can set up folders to represent your site, to be able to store this information, so that you can not only find it under a physical hierarchy of how that device is connected up through the various control systems or PLCs, but also allowing you to look through folder structures. So being able to have a single centralized, organized inventory of all your assets, that's always helpful as well, a different way to find them. But why are you pulling this information in? One of the reasons is documentation and compliance. I want to know if, and it goes hand in hand with this next one with change management. If we're pulling all this information into these devices and we have all that configuration information, if we have data like what alerts were set or cleared, or who logged onto the system, what changes did somebody make, what's the as found and the as left data, all of that information is accessible either through the live device connection, through the physical hierarchy, or in the logical plant database hierarchy here as well. So those are some other considerations. Going through a few more is that once you're live with these devices, not only are you going to be able to do something like monitor the health of them here, which is I need to know the condition of the assets out in the field of all these instruments or valves or vibration transmitters. We're able to monitor those to give you credible information so that you know if you can take corrective action right now, or if you need to plan and schedule work for it. So monitoring the health of those devices is really important, and that's having an online access and an online interface to those field devices from any manufacturer out in the field to be able to pull that into a centralized system to monitor them. But if you're lucky enough to be in a startup or an expansion, maybe you're going to do commissioning activities. Otherwise, you may be doing troubleshooting, you may be doing configuration. And again, instead of grabbing a handheld unit to go out to the field and do the work out there locally at the device, wouldn't it be nice just to be able to do that directly from an asset management system, from the shop? And so you're able to look at the device with the right user security and privileges. You'll be able to make changes to those devices out in the field without, or from the safety of a shop versus having to go out into the field. Now, there's also capabilities to look at is that if you get beyond this point of starting out just to have an online connection to monitor the health of these, to do some troubleshooting so that you can plan and take corrective actions, maybe a next step is to do some predictive diagnostics. And so there's some advanced applications for types of devices. A lot of people start around control valves, just mechanical moving parts, wear out faster than a sensor or a probe on a transmitter. And so they want to do diagnostics on those. And so there's lots of manufacturers that have advanced valve diagnostics that are built into these asset management systems or offered as an option. And so that's one way to do it. There's other advanced applications around doing interlock verification. There's other advanced applications for doing things like meter verification. That could be for meg meters or Coriolis meters or vortex meters to tell you the structural integrity of the Coriolis tubes, or if there's coating on any of the probes in the devices as well. So that's some other things. The last three things I would mention to take advantage of, and you'll get these slides afterwards to look at these to say, hey, what would I look at to compare different products out there to be able to look at these? One of them may be, hey, I want to just use this tool to do my job, to take corrective actions, to know the condition of the equipment, to do my job more efficiently. But you may also have people that are saying at your site or at a corporate level, you can do what you need to do your job, but I need to have access to this information. I want to have some of this flow up to a report. I want to have it flow up to a dashboard. I want to have it flow up into, let's say, a maintenance management system, and to have standard ways to get data out, whether that's OPC or MQTT or XML Web Services. Those are just some ways that you're maybe able to pull this information out of these systems. So it may not be something critical to your role, but it is something that a system should be able to do to help facilitate the analysis of information up at a higher level. Then you get into scalability. A system should meet your needs today. You don't have to start off with a large single one-size-fits-all for your site. You would be able to start off with something to say, I just want to look at the devices, instruments, and valves over in this area, or I just want to look at all the control valves at my site, or I want to scale up later on and add more. I want to add another area of my site into AMS Device Manager, and being able to do that. So a system should be scalable and grow as your needs change or adjust. The last thing I would say is different manufacturers have these asset management systems. And so how big is that manufacturer? Do they have global representation? Do they have different offices or support organizations that are relatively local to where your site is? You don't have to call into one location within, let's just say, a world area for support. If you need somebody out there, you want to be able to get them out as quick as you can, people to help troubleshoot things to do that. And so just looking at the different vendors that are out there, it's a way to help know what kind of support you might be getting for these different asset management systems out there as well. And so with that, Anna, I think we have another polling question.
Yep. So I just started that poll. Really, it's a simple, which of these features that Eric has just talked about is most valuable to you if you were to have an asset management software solution? What would be the key thing that you're looking for, or which feature would be most valuable to you, most important to you? And looking at the results here, overall winner, it's the health monitoring and predictive diagnostics, Eric. So I think with Tin's overview earlier as well, and with the features that you talked about here, I think people are really looking forward to use those smart diagnostics and help them improve the reliability of their instruments and valves. So that's what we have right now. Second is the change and configuration management, which is typically what we hear from our customers too, right, Eric and Tin?
Yes,
So those would be
definitely.
the key things. Yep. Health monitoring and predictive diagnostics and change and configuration management. Right. Cool.
Thanks, Anna.
Right, thank you,
And
Anna.
while we're doing that, yeah, let me just take control of the screen here.
We're coming to the end of the presentation area webinar. If you still have questions questions, please use the Q&A and ask the question. We are responding to as they're coming in right now.
Mm-hmm. Thanks for the reminder, Tin. So I'll just go through a few case studies here. So Eric did a great job and Tim did a great job going through an overview and the features of an asset management system. And I think now everyone has an idea about how they can fit an asset management system into their existing work processes. So let's look at some real life examples of how users who have already implemented an asset management system, how they were able to get the benefits out of their successful maintenance program. So I only have three here, but there's actually much more available out there, but I'm just going to go through three of them. So the first one is a biotech facility. So they observed significant operational and financial benefits by because they were able to do real-time monitoring of hundreds of their smart devices and valves. So the maintenance people also are they're only doing the work when it's truly needed because they already have the diagnostics. They know if it's really not required, then they won't do any maintenance work. So they were able to reduce the number of valves that they overhaul by 400%. And this not only improved their reliability, but it also helped empower their teams to really adopt a predictive strategy across their facility. So with that, they were able to save 2,000 man hours per year annually. So that streamlines really the workflows and the amount of paperwork and documentation that they need. And then, secondly, we have at a chemical plant, their asset management system enabled them to detect the device issues early. So this proactive approach really helped them prevent costly failures and were improving the valve performance. And also, it also helped with their maintenance planning. So they also use intuitive dashboards and have access to device diagnostics so that the team is able to make informed decisions to improve their reliability and avoid production upsets. Now, the technicians, because they are able to do, since they already have intuitive dashboards, they can monitor their instrumentation remotely. So this doesn't just reduce the downtime since they have real-time data, but it also improves their safety because that allows their maintenance personnel to really spend less time in hazardous areas because they don't really need to be in the field to look at the health of their asset management of their devices. So furthermore, this customer, they talked about an emergency shutdown that they prevented, and so they avoided about 6 million in revenue loss by detecting a faulty pump bearing much earlier than that it would have it didn't affect the production yet or the process yet. So again, advanced diagnostics of an asset management system was able to help them turn diagnostics into dollars into savings. So lastly, we have a polystyrene plant. So they transformed their maintenance strategy from a reactive to a predictive strategy. So their operations became more efficient, more reliable, and cost effective. So their team, similar to the previous one, their teams were able to spend less time on routine calibration um, and avoid unnecessary valve maintenance. So they were able to free up their resources to do something else, right? Something more important instead of unnecessary valve maintenance. They were able to cut down their calibration time by 60%. And also, they were able to increase their product value by 1.5 million. So this shift from reactive to a predictive strategy didn't just reduce downtime, it also boosted the productivity and the production by nearly 7%. So there, as I said, there are still many success stories documented, and you can even create one for yourselves once you use an asset management system. But if you want to estimate the potential ROI for your site, we actually have we actually have a very simple ROI calculator. So you can just enter a few parameters there so that you can put in the rate of the maintenance personnel, how many smart devices you have, and the approximate cost of production shutdown or slowdown if it occurs. And then it'll provide you some estimates of how much you can save during the startup and commissioning phase, or even throughout the life cycle of your plant. What would be the annual savings if you had an asset management system? So yeah, these are all the links to these the a copy of these slides and the links to these websites and the case stories will be available to you once you have the presentation slides. But for now, I think we want to thank everyone for joining. But before we go, any parting words, Tin and Eric? I wanted to have a draft poll, a poll here, just to see if anyone wants us to, have a follow up with you for a more detailed discussion. We will be sending out a survey so that you can provide us some feedback regarding this webinar. And yes, definitely we'll talk to you more if you want us to follow up with you with a more detailed discussion, a demo, anything really. If you have any questions that you didn't get to ask today, let us know and we'll do a follow up call with you guys. Anything
I
else,
appreciate
Eric Tin?
I appreciate it, Anna. Yes, we probably send a survey to see what other webinar y'all like to see and so forth, right? And as well as how we can help you out throughout your life cycles of your instrumentation and bio maintenance strategies. So just let us know. We here. We are on LinkedIn. There's our
Yep.
scan code that you can connect to us if you like, and ask
Exactly.
us question as well.
All right. There were so
All
many
right.
hearts and claps there. I love
Okay.
it.
I appreciate that, guys. Hopefully, we bring a lot of value
Thank
to
you
your
very much for the
organization.
time.
Thank you.
Yep. Thank you so much, everyone.